video we're going to find out how we can isolate a variable. First of all, we need to realize that we are talking about equations. Okay? So, when we talk about equations, we are talking about something that is the same in one side to another. And in that case, we are dealing with same values on both sides on the equal sign. For example, in a very practical and pragmatical way, if we get, for example, square, okay, we could say that a square is equal to another square. In other sense, we can say that 3 is equal 3. Or in another way, like more child way, we can say that one cherry is equal to another cherry. But these are just approximations of how we can form an equation and what an equation is. But in other situations, we are not in front of so easy equation forms, and we are going to use some letters that we can call variables. And for practical senses, we use variables with the letters x, y, and z. And probably we can use other letters of the alphabet, maybe P or maybe Q or maybe R or maybe S. Well, that depends on the author and the book you're using, but normally we use x, y, and z. For example, we got an equation that could be x is equal to y. This means that every 2 times that I multiply a value of y, we will get one value of x. Or, seeing in the other side, we can say that one value of x is equal of 2 times y. And we are managing here equations. But there's an important thing that we don't only use letters. What does this mean? That we can use another kind of nomenclature that means something. For example, imagine that you are trying to use a formula with a triangle, and we're going to write down the area formula of the triangle. This is the area is equal of base plus height divided into 2. Or if we can put it in another way, we can say that 1/2 or the base and the height. These two expressions are quite the same, or the area. So here we have another letters and another form to represent different situations or different data of an equation. For example, we can say here that A becomes from area, that B is the same of the base, and that H is the height. Okay? So, considering this, we can have here an equation, and we can use this data in order to isolate the variable. For example, imagine that you got this equation and you need to know just how much will value the height, just the h. So what we need to do here, okay, it's very simple. We're gonna get again the formula. Area is 1, it's equal to base plus height divided into 2. So we learned in school that something that you get in your right part of the equation comes to the left side with a different or with the opposite mathematic problem or the opposite operation. For example, we could have in mind that the opposite operations for the addition is the subtraction, and obviously for the subtraction is addition. Then for for the multiplication is the division, and from the division is the multiplication. And we should know that an exponent, the opposite will be the square root. So, well, it depends. A square if it is a square, and it could be cubic if it is a tree or whatever. So these are the opposite situations. So with that in mind, we can say that if something is, for example, in this case, these two, because we are wondering to leave the h alone, so we need to take out the 2 and we need to take out the b. So considering that, remember the 2 that is involved in this equation here is dividing the v and the h. So we can take it to the other side, but as a multiplication. Why? Because the opposite operation for the division is the multiplication. But the real thing that we are doing is that we are putting that thing as a multiplication in order to eliminate that in one side, and as a result of doing that in the other side, we apply the multiplication on the other side. So to avoid or to eliminate this 2 that is dividing the base and the height, we need to multiply this side by 2, and at the same time we multiply the side by 2 on the other side. What is going to do this? We're going to eliminate this one, and we're going to leave just this. This means that 2 times the area is equal to the base multiplied by the height. Now we're just one step behind of leaving the height alone. We can turn this equation from the original position and the value will remain. And why do we do that? Because normally we want on the left side the value we're looking for. So 2 times the area, it's equal the base plus the height, is exactly the same that the base multiplying the height is equal to 2 times the area. These two are exactly the same. Okay, so considering that, we can put it in this position from now and on. Now we're going to leave alone the h, and again, what do we have here? A b, and we need to eliminate that b, and the b is multiplying the height. So what we need to do to eliminate that b, we need to divide this expression into b. So this means that I divide this side by b, and that means that we divide this side by b. So now we can eliminate this one with this one, and we remain with this. So height is equal to 2 times the area divided into the base. According to the way that they teach us when we were younger, base multiplied the height is equal to 2 times the area. This is multiplied, we take it to the other side, dividing. So height is equal to 2 times the area divided by the base. So this is quite the same than this. But in this form, we find out the right way to do that. That is, if you want to take out something from one side, do the same thing one side and another side of the equation, and you will keep the balance in that equation. So this is the way we're going to isolate a variable. And this happened, well, this is example to get the area of a triangle, but we can get the same result isolating any other variable, okay, of any other equation. For example, if we clear everything here and we're going to think about a new equation, for example, let's think, I don't know, maybe x is equal to 2 times y minus 5, and imagine that you want to isolate y. First of all, we can change the position in order to get the variable on our left. So we can say that 2 times y minus 5 is equal x. Now, to eliminate this minus 5 from this side and be closer to isolate the y, we need to add 5. So 2 times y minus 5 plus it's equal to x plus 5. So we can eliminate this and this, and 2 times y, it's equal to x plus 5. In another way, we could say it as the old-fashioned way we learn it, that this is subtracting here and we take it to the other side as an addition. That's exactly what we did here. Now, keeping working with this, we need to isolate the y, so we need to take away this 2, and this 2 is multiplying y. So how we can take it up the y, dividing this expression into 2. So 2 times y divided into 2 is equal x plus 5 divided into 2. And we can take away this 2 and this 2 and keep this one. So this means that y is equal x plus 5 divided into 2. In the old fashion that we learned it, we could say that this 2 is multiplying y, and we put it in the other side as a division. And that's exactly what we have done here. And with this in mind, we can have our final result. Well, this is just a brief explanation of how we can isolate a variable from an equation. And this is very, very important in order to get another kind of results in another situations solved in an equation. For example, we can take this before substituting values in the variables, and that means that this is kind of a previous step before getting into the function world. That's one of the following topics, and we're going to get some extra videos for you to have more explanations. Thank you very much, and I hope that this helped you.